Calculating relative frequencies in Python. Thank you for joining this session. Today we're going to review how to calculate relative frequencies using Python. This is a section within Analytics for Living's Statistics Python Applied Learning course. Within that course, there is a section called Describing Data with Tables and Graphs. Before we get into calculating relative frequency, we're going to walk through a little bit of background. A frequency table. The frequency distribution is a collection of observations, and then there's also discussions around frequency distribution for ungrouped data, which are produced whenever observations are sorted into classes or single values. Frequency distribution for grouped data, a frequency distribution produced whenever observations are sorted into classes more than one value. There are, of course, real limits located at the midpoint of the gap between adjacent tabled boundaries. Frequency distributions. As part of the course, we do provide guidelines for frequency distributions. In this case, the example is of weight of individuals, both at the 245 to 249 weight, there's 1, whereas 240, 244 is 0. The calculation in this example is that there are 53. The 53 calculates is the total, and then the frequency distribution can be done within the intervals. Of course, one consideration is outliers, which is very rare, but the recommendation is that when you do have an outlier is to segregate, not to suppress. The example I gave above was here's the chart related to relative frequency distributions. In this case, I mentioned the weights, the frequency distribution. The way the relative frequency is calculated, it sums all the observations. So in this case, there's 53. So the denominator is 53 divided by the number by weight. So in terms of 1, it's 1 divided by 53 is 0.02. And if there's 0, of course, there's 0. And accordingly, you'll see that largest with the 17 and 151, 159 is 0.32. Now we're going to jump into the example using Python code. So the example we'll give here is, let's consider a survey conducted among a group of 100 students to determine their favorite subjects. The survey results are as follows: mathematics 35, English 25, science 20, history 15, and art 5. To create the relative frequency distributions, we need to calculate the proportion of percentage of students for each subject. Here's the relative frequency. So as we mentioned, the sum of the students is 100. So mathematics is 35 divided by 100. So the numerator 35 divided by 100 is 35. And we do that accordingly for the English students of 25%, or students that say English is their favorite of 25%, science 20, history 15, and art of 5. So the relative frequency distribution shows the proportion of students for a preferred subject out of the number of the students surveyed. Now let's jump into the code. In this case, we're using Google Colab. Of course, this code will work in a Jupyter notebook or any other tool that utilizes Python code. So the first step with this is to install the packages. The statistical packages in Python that enable you to calculate relative frequencies are NumPy and Pandas. So the first line of code is to put a hashtag just to state what is this description of this row of code that we're going to put in. To import NumPy, we write import NumPy as NP, import Pandas as PD. Once that's written into the line, the code will recognize import and recognize the as. We hit run. Run can be done at the top to run the quick code, or you can click on the triangle, or you can hit the shift enter key to run as well. So we're going to run this code to install the packages so quick. Right? Now the next part was to take the data that we had, subjects, mathematics, English, science, history, and art. Be conscious of putting in single quotes at the end because these are text strings, and text strings require a single quote in most cases. In some cases, in more advanced course, you'll see where double quotes are needed, but in this case, it's single quotes. Next, we'll put the counts. So the 35 refers to mathematics, 25 to English, 20 to science, 15 to history, 5 to art. The formula is total students equals the sum of the counts. The relative frequencies equals count divided by the total students for the count in the count. So the total students would be 35, the sum of the 35, that's what this formula is saying, and the count would be the count within each of the subjects. To enable that to come in a table, we write the for clause. For subject, so subject is math, English, science, history, art, the frequency in the subjects and the relative frequencies, colon, the percentage equals the frequency times 100 because we wanted 100%. As you saw before, it's a ratio, or up in this example, it's 0.25. We want 100%. We'll multiply that by 100. And we'll print the subject, colon, and the percentage. We put in quotes so that it would list out those as well. So now we're going to hit the run as we mentioned. And there it is, the table of the results of the relative frequencies. That's simple.